Hey guys, how's it going? I wanted to show you section 3.2. So the biggest thing with section 2 is, first thing is, it's all applications of section 1. So it's all just going to be SOHCAHTOA. The math itself should be, for the most part, pretty easy for you. The hard part is actually going to be drawing the sketches. So when you look at the homework page, the first thing you're going to notice is the first few problems are going to be sketched for you. I highly recommend when you do these, cover up the book sketches, draw the picture for yourself from the story problem, and then see if your sketch matches the same as the books. The reason that's important is when you get to the last few problems, you're going to notice they're not drawn for you at all. So you're going to have to draw from the sketch. So the biggest thing here is, can you do the drawings? Okay. Now, so with some of these problems, you're going to see that a lot of it's about this angle of elevation, angle of depression. Okay. So first thing I need you to understand, and yeah, you guys are going to probably make fun of my drawings, but that's okay. I'm going to make fun of yours too. So angle of elevation, if you are on the ground, okay, if you're down here and you are looking up at an object, okay, we call this the angle of elevation, the angle from the ground up to that angle out to whatever you're looking at. That's called the angle of elevation. The angle of depression is if you are, like, say, up in a plane looking down at something. Now, you have to draw a parallel line to the ground, and then the angle that forms with the ground, that's called your angle of depression. Now, with some basic geometry of some alternate interior angles, it's pretty easy to see that your angle of elevation, your angle of depression should always be equal to each other. So if this angle of depression, let's say, is 15 degrees, that means this angle of elevation is also going to be 15 degrees. So that's very, very important to remember. Your angle of elevation, your angle of depression should always be equal to each other. The most common mistake people make doing these drawings is when they read something, they see angle of depression, they put the angle here. This is not going to be your angle of depression. Okay, your angle of depression has always got to be from a parallel line to the ground. Okay, so story problem could read, you're in an airplane, you measure the angle of depression at 15 degrees to the airport, you're at 10,000 feet. What is the ground distance that you are away from that airport? So you have to solve this. Well, if you know that this is 15 degrees, you also know the angle of elevation, if someone was looking back at you, has 15 degrees. And now from here, you just have a basic SOHCAHTOA equation. Which two sides are in play from the angle? That's opposite, that's adjacent. It would just be tangent of 15 degrees is equal to opposite, so 10,000 feet divided by x, opposite over adjacent. And then you can just butterfly that with your calculator, okay? Making sure that you are in degree mode. Always make sure. One of you guys, this next test, is going to do the whole test and forget to change your mode, and every single problem is going to be wrong. So I would do 10,000 divided by a tangent of 15 in this case, and your answer would be 37 feet, or 37,000 feet, okay? All right, so here's a very basic example, but the biggest thing is making sure you understand what an angle of depression is versus what an angle of elevation is, okay? Now, some of the problems could be very basic like this. You could also run into a problem like this. Let's say you're on the 5th story of a building, or you know that you are 50 feet in the air. You measure an angle of elevation, okay, from where you're at to a different building, and you measure that to be 25 degrees. You know the two buildings are 200 feet across. Your job is you want to find the height of the other building. Well, if you know this is 50 feet, you also know this is 50 feet. If you know this is 200, you know this is 200. We can solve for this, right? Basic opposite adjacent. That would be tangent of 25 is equal to opposite over adjacent. And again, you can just butterfly. So in this case, I would do 200 times the tangent of 25. I'd get that answer. X would be, sorry, this can be 90. I need to multiply that by 10, so didn't have enough zeros in there. 200. Come on, go over there. Put that 0 in there. Okay, so it'd be 93 feet. And then we would know all we would have to do is add that 50 in, and we would have the height of the building as 143. Okay, so that's another use for angle of elevation, angle of depression. And just so you guys are aware, measuring these angles is actually a really, really easy thing to do. What you can actually do is, you know, if you were, let's say, going to measure these really precisely, you would need, oh, come on, why is this, let me, come on. So you would need what's called a clinometer. I wish I could move this. All right, so can I make this smaller? There we go. All right, so if you have what's called a clinometer, and you can make one out of a basic protractor and a piece of string, you know, you can buy fancy ones that, you know, real surveyors would use, but you can also just use your phone. You guys have all seen the compass app on your phone, or I personally like this Handy Level app, right? So if you download this Handy Level app, you can, you know, use something like this. What I actually like to do with this is, you know, if we were in class, I'd have you measure something in class. We like tape a straw to the side of your phone so you can look through it like a scope kind of thing. And then you can use that to eye something. You know, you could put a laser on it or something like that to make sure it's precise, but you can use something like this very simply to measure that angle. So measuring that angle is actually something really, really easy to do. Okay. But these same types of problems could be slightly more complicated depending on what information you know. Same kind of idea. You know you're off the ground, but maybe you don't know your height. Okay. You do know how far the two buildings are away from each other, though. So what you actually could do is you could measure the angle of depression from where you are to the base of the building. So let's say that's 20 degrees. And then you could also measure the angle of elevation to the top of the building. So again, remember, angle of depression is from a parallel line to the ground down. So that's the angle of depression to the base of the building. Angle of depression or angle of elevation up to the top would be 30. Okay, if we know this is 500, we also know this is 500. Well, now you just have two separate SOHCAHTOA problems. We can solve this from the 20, opposite adjacent. So tangent of 20 is opposite over adjacent. And then we can use this one, we'll call this one y, from the 30, opposite adjacent again, right? We can do tangent of 30 opposite over adjacent. We can solve both of these separately and then just add them together. So, these two types of problems are very similar, but they can be solved in slightly different ways, okay? Now, a little bit more complicated problem. This one I actually ran into in real life, and I've done this in the past. Story was this. I helped my sister move down to Arizona. If you've ever been to Arizona, it's a very flat landscape, except every once in a while, just a random mountain pops up. So, I helped her move down there. We got all our furniture in the house, and we just, it wasn't too hot of a day. We said, that mountain over there looks pretty cool. Let's take a hike. Well, there's two important pieces of information you really need to know before you embark on a hike. Well, one is, how far is that mountain really away? It may look close, but you never really know until you actually calculate it. Looks can be deceiving. It could be miles away. The other thing to make sure you understand is, what is the height or the height of that mountain? Okay, we really need to know those two distances, because if you don't, you're going to embark on a hike that you may not be ready for. So the question is, how do you calculate those two distances? And this is actually a really easy thing to do. So what you do first is, from where you're standing, you measure the angle of elevation. Let's say it comes out to 10 degrees. Okay, so I did this. Grabbed my phone. We very easily measured that angle of elevation at 10 degrees. And then what you do is you walk a set distance towards your object. Okay, so let's say we walked 150 feet. Okay, obviously the farther you walk, the bigger the gap is going to be, but the bigger the change. And then you remeasure the same angle of elevation. Now, what should happen is that angle of elevation should increase. It has to, right? So if it was 10 degrees before, now it's 12 degrees, okay? So that is actually all the information you need to calculate both distances. So you can do this without ever actually getting close. So now let's see what we got here. Let's let x be the distance from our second point to the base of the mountain, okay? Now, from the 12, we can set up a basic proportion, but it's opposite adjacent. It would be tangent of 12 is equal to opposite over adjacent. Now, that proportion, tangent of 12 is y over x, that actually can't be solved on its own. Well, let's see what would happen if we do tangent of 10. Tangent of 10 degrees, okay, would equal opposite, which is y, over adjacent, which is this whole side, which would be x plus the 150. So it's going to be y over x plus 150. Now, neither of these two problems can be solved individually, but what you can do with these, this is nothing more than a system of equations. We can solve this using any form of, or any method of system equations you like. I personally like the substitution method. First thing I would do here is butterfly, which would give me y is equal to x times the tangent of 12. And I need you to understand this tangent of 12 is nothing more than an ugly number. It's just a decimal. It's, come on, turn on. This will go faster if my calculator would work. So tangent of 12 degrees is just an ugly little decimal. It's 0.212. So we're going to treat this as 0.212x, okay? And now we're going to do the same thing over here. We're going to butterfly, and we're going to get y is equal to, well, we would really need to distribute down here. So I need to do tangent of 10. Okay, tangent of 10 times x is going to be 0.176x plus, and then I have to do tangent of 10 times 150. Okay, so 26.44. Okay, and now I have these two equations. Well, this is equal to y, this is equal to y. I can just set those equal to each other, right? So I can substitute this in for y, and I got 0.212x is equal to the 0.176x plus the 26.45. Okay, this is just a ugly basic equation, but I would subtract. So I want to do, here's where I would never estimate. I want to use as many decimals as I can. So I want to do that 0.212 number. I want to minus the 0.176 number, and I would get 0.036x's equals that 26.45. And then I would just need to divide. So I want to do that 26.4 number, and I want to divide that by that 0.03 number. And I would know, in this case, x is equal to 730 feet. Now, if that was the case, I know this distance down here is 730 feet, which means that mountain is not very far away, okay? By the way, I just made these numbers up. These were not the actual real numbers when I did this. And then I can also substitute this back in either one of those two equations. I would substitute it right here. So all I really have to do is take that number and multiply it by the 0.212 number. And I would know the height of the mountain is 155 feet. Now, if that was the case, I would absolutely go on that hike. It's not a very tall mountain. I wouldn't even call it a mountain. It's more of a hill, and it's not very far away. When I did this in real life, it came out to the distance I was to the mountain was about 4 miles, and the altitude or the height of that mountain was about 3,000 feet. So I said, you know what? I'm going to pass. But, it's a very, very simple calculation to do. But you do have to set up basically a system of equations, okay? So there is one of those like that in the homework. Try the homework. I don't think you guys are going to find too much problem with this homework, but I will say make sure you do draw the sketches. The one rule I am going to make sure you do on this homework assignment is you have to draw a sketch. Your drawings at a minimum have to be at least as good as my drawings, which isn't a very high bar for you to jump. This sun is really bright today. So your drawings have to be at least as good as mine. And this is one homework assignment I wish we were in class for, if you want to take some extra time and draw some really, really fancy drawings. My art extra credit on this assignment is going to be very, very stingy. But if you want to take the time to draw some really, really fancy drawings and color them and put some time and effort into those, I will throw some extra credit your way as well. So if we were in class, I'd have a competition and, see who actually has some real art skills. But you guys have a little extra time on your hands these days, so I'll just open it up to anyone. But again, I am going to be pretty picky on how the quality of your art. Here's where I get to kind of judge you, okay? So try a few of these and let me know how it goes, all right?